Hi there, welcome back. So let's look at another second order effect. We did cover body effect before this, and today we will look at an effect called channel length modulation. Channel length modulation. So before we look at that, let's look at how the channel looks between the source and the drain in a MOSFET under the application of different voltages. So for the first case, let's say the source and the drain voltages are 0, and we give a certain positive voltage to the gate. What happens is we've already seen, of course this is the oxide layer. What happens is, because of the positive voltage from the gate, and this being the P substrate, forgot to write that, okay, so this being the P substrate, which is abundant with holes, the positive voltage at the gate tends to repel holes from this place. Alright, so when they're repelled, we are left with hold on a second. So what we are left with after they're repelled are negative ions, correct? So this is clear. We give a further positive voltage and we're gonna have another layer of negative ions. This is a negative ion, sorry. Alright, now this is fine. What you have to see is we've been applying voltage only at the one terminal that we know is the gate, and we have a nice uniform channel thickness here and length. Suppose, just suppose, we put some positive voltage at the source. Let's see what happens there. So we give a positive voltage at the source and gate is already positive. Let's give them numbers so that it's easier to analyze. Say this is 0.5 volts and say we give a 0.2 volts at the source. What happens to the channel is now this area is going to have a different voltage as compared to this area, correct? If you see the voltage difference between the gate and the drain, it is going to be 0.5 volts, while here the difference is 0.3 volts, correct? So the positivity of the voltage above the channel is 0.3 volts for the left part of it and 0.5 volts for the right part of it. So what happens if the positivity is lesser on one side? The less positivity is going to repel holes that much lesser, right? So you will have more hole dominance in a place that is less positive. Understand? Because they don't repel as effective as 0.5 volts will. So what happens is, here you have the same negative ions in two layers, but here what happens is you have only one layer. You understand why? Is because there's a weaker positive force here repelling the holes, so the holes will line up near as compared to this right part of the MOSFET. So what happens? Now how does your channel look? It looks like this. It's got this little gradient like shape. Okay? And suppose we increase this to 0.3 volts. Your effective is going to be 0.2 volts here, right? The 0.2 volts is even lesser positive. So what happens is this thing goes even further, up. So your channel length, actually the thickness is reducing, but if you keep reducing it further and further, what is going to happen? Let's look at a new diagram. This has gone really way too congested. So what happens is your channel that looked like this is going to go like this and this and this. So you're going to keep on reducing the channel length after a certain amount of time. But in general, with MOSFETs, what we do is we don't use we don't generally give voltage to the source. We keep it grounded, and at least for now let's consider it's grounded, and we give positive voltage to the gate, and to the drain we give some positive voltage. So as I told you, just like the source side modulation, the same thing's going to happen with the drain side, and we've covered this with the derivation of current equation in a MOSFET. Okay? The more you increase your drain voltage, the difference between the gate and drain is going to go down, and holes are going to dominate this place all the more. So your effective channel keeps reducing. Alright? This reduction in channel because of the positive voltage on the drain is called channel length modulation. This is all there is. So what you have to understand is channel length modulation is because of the changes in the drain voltage. We generally call it VDS because source is anyway grounded, so it really doesn't matter. So it's the VDS. Alright? So the length of the channel is now a function of VDS. So if you change VDS in your design, you have to understand your channel length is going to modulate. That's all there is to know about channel length modulation. Of course, when we come across a few problems, you'll understand better. Thank you.